All right, good morning, ladies and gentlemen. It is March 2nd, 2021. Welcome back to another session of ICP. Today we're going to be continuing our discussion of chemical bonds. And today we're going to learn a new type of chemical bond called a covalent bond. So one really nice thing about today's lesson is it's going to do a good job of reviewing ionic bonds one more time. So if there was something that you missed or didn't quite understand, this will be a good opportunity to get caught up on it. So for the do now, we breathe in oxygen, so we take out of the air. The chemical formula for oxygen is O2. Try to diagram this as an ionic bond. Does it work? Why or why not? So what I'm going to do is I'm going to pull up a whiteboard. All right, here we go. And what we're going to do is we're going to diagram the bond for O2, okay, so oxygen. Now, if you look at your periodic table, oxygen is in group 16, and therefore it has 6 valence electrons. 1, 2, 3, 4, 5. I'm going to put it on this side for reasons you'll see in a second. So there, it's got its 6, and we're going to add that to another oxygen. It's 6. Okay. And now remember, in an ionic bond, we have one atom transferring electrons to another. And this makes them both become more stable. And that's the key. They both have to become more stable. Now, if we look at this, remember, everyone wants to get to 8 valence electrons. And we see 2 oxygens next to each other. I see each one is looking for 2. There's 2 missing electrons from each. So I'm looking for 1 here and 1 here, and the same over here. Now, the problem is no matter how I transfer these, there is not a way for me to get both of these to 8 or 0. So the problem with that is I'm not going to actually be able to transfer electrons. And if I can't gain or lose electrons, what's the next best thing? Well, the next best thing might be to share. So obviously this is not going to form an ionic bond. There's no way for them to transfer the electrons so that each atom is happy or more stable. And so therefore we're going to have to look at some other methods. Now, what we're going to see today is, like I said, if atoms cannot gain or lose electrons, they might start sharing them. And so what they can do is they can share pairs of electrons. And even though neither one has a complete set of 8, these electrons that I've circled, these 4, are going to go around both atoms. And so it's going to kind of trick each atom into becoming more stable, even though they technically don't have a full stable octet. We're going to see that the sharing really does make them become more stable and form a chemical bond. All right, so let's go back to the PowerPoint. All right. Covalent bonding. So we're going to be taking a look at it. I don't know if you guys can see that or not. All right. So again, to review an ionic bond, yesterday we took a look at atoms that either gave up or stole away electrons from another atom. So remember, we had the metals. The metals are on the left side of the table. They usually have 1, 2, or 3 valence electrons in their outer shell. And so what they're going to do is, instead of trying to gain a bunch of electrons, they're just going to get rid of those electrons, give them away. And then we also had a non-metal. Non-metals have 5, 6, and 7 electrons normally. You know, there's obviously the 4 that's kind of in the middle. But what they're going to do is they're going to be gaining electrons to bring them towards stability, to get to that magical 8 number. So those were the 2 options. Now, this type of tug of war between a metal and non-metal we call an ionic bond. And ionic bonds form salts. Now, not always the salt that we put on our food, but that's just the kind of bond or the result precipitate that is formed when these 2 types of atoms interact. So no matter what, we're going to call it a salt. But remember, only sodium chloride, that is the table salt, NaCl. And hey, look, here it is. Sodium has 1 valence electron. Chlorine has 7. Sodium is going to give away its electron to chlorine, making sodium positive and chlorine now negative. And it's this charge, these opposite charges, that causes these two atoms to stick together. Sodium has a full outer shell of 8. Chlorine has a full outer shell of 8. Both have become more stable. So now we're going to learn about another type of bond where you can't gain or lose, but you can share electrons. Covalent bonds are atoms that are held together by the sharing of electrons between non-metals. And this is going to be the biggest difference. The easiest way for you to tell if you're looking at an ionic bond or a covalent bond is to look at what types of atoms are interacting. If it's both a metal and a non-metal, chances are you're looking at an ionic bond. But if it does not contain a metal, like our example from this morning or from the do now, 2 oxygen atoms, that's 2 nonmetals. They're not going to be able to gain or lose, but they can share their electrons to form a covalent bond. Okay, and what's key, what's really important to understand, is that these 2 electrons orbit both nuclei of the atoms. So they're going to go around one and then they go around the other, and that kind of tricks things into a state of stability. So remember, it had to be a metal, which became a cation when it gave away its electrons, cat positive, and a non-metal anion negative. Non-metal gained electrons that made them negative. We call them anions. And they held together by those different charges. Once they've shifted the electrons, and they form salts. A group of atoms joined together by a covalent bond is called a molecule. Now, a compound is a group of 2 or more atoms bonded together, elements bonded together. It could either be ionic or covalent. So if we're talking about molecule, chances are we're talking about covalent bonds. But if we talk about a compound, you have to be a little bit more careful because that could be ionic or that could be covalent. So again, this is just a really good picture to visualize the differences in what is happening to the electrons between the 2 different bonding types. Here on the left, we have 2 hydrogen atoms. They each have 1 electron, 1 proton. And what are they going to do? They're going to share those 2 electrons. Now, why is hydrogen only happy with 2? Because remember, the first shell can only hold up to 2 electrons before it's full. So this is this and helium are the only atoms that are happy with less than 8 in the outer shell. So a key here again is these are going to share, so these electrons are going to orbit both nuclei. But if I'm doing an ionic bond, one atom is giving away its electron to the other. That makes one positive and the other negative. And this is the example of an ionic. So one has them, one does not. In this case, they are sharing. This is also very important because if something causes them to break up, the electrons in the sharing, you take your stuff and you go, right? So like if you split 50-50, it's going to take its one atom's going to take its electron back, the other atom's going to take its electron back. But the key is in an ionic bond, that transfer is permanent. Once that, well, mostly permanent. Once that electron has been given away to the other atom, that atom can't get that electron back. So for example, think about salts. What do salts break down in? They break down in water. Right? Salt dissolves in water. Why is that? Well, it's because water actually has a charge. So the positive end of water takes away this negative half. It rips it apart from the positive, and the negative end of water takes away this positive one. So salt dissolves in water, okay? Being pulled apart by the attraction of the charges. But the key is once the salt breaks down, or is dissolved rather, it doesn't revert to its original properties. Sodium doesn't go back to being an explosive metal because it's already gotten rid of that electron, and so it's not reactive anymore. And chlorine is not going to be that poisonous gas anymore because it's gained that extra electron. And even though they've broken apart from each other, they still retain those properties, one having no electrons and the other having them all. Well, I shouldn't say no electrons. In sodium chloride, sodium is just next shell down is full, but I was looking at the hydrogen example or the simple element example. Okay. So moving on, what are some properties? Well, properties of molecular compounds are they're usually liquids or gases at room temperature. There are some exceptions, but for the most part, they're either going to be liquid or gas at room temperature. Again, because we're talking about the nonmetals. They also have lower melting points than ionic compounds, which means that they have a weaker bond than ionic bonds. The sharing, remember, it kind of tricks it into stability, but it's not really as set in stone as the ionic bond. Ionic bond is more permanent. Covalent bonds can be broken and reformed quite easily. Okay, this is just a counting activity. This is kind of leading us into where we're going to get into later this week and next week, talking about balancing chemical equations. But what we can see here is, remember, chemists are lazy. If there's no number, is a 1. So it's just asking how many atoms are in each. And these are multipliers. So how many hydrogen atoms there are there? There are 2. So there are 2 total atoms in number 1. Here I have 1 carbon and 1 oxygen. So there's 2 atoms in number 2 as well. Here I've got 1 carbon and 2 oxygens. That's a total of 3. Here I have 1 nitrogen and 3 hydrogens. That's a total of 4 atoms. And here I have 2 carbons, 6 hydrogens, and 1 oxygen for a total of 9 atoms. So again, these are multipliers, but just to their element. Okay. We're going to skip over this for the sake of time. All right, so again, here we can see some of the differences between ionic and covalent. Ionic gain and lose, and then they're permanently, they're changed, and those charges that they occur or that they gain cause them to stick together. Covalent bonds are held together because there's 1 or more pairs of electrons that are being shared between the 2 atoms. All right, so if we compare them side by side, ionic and covalent, when we form an ionic bond, we call it a salt, whereas when we form a covalent bond, we form a molecule. Remember, ionic bonds transfer, gain or lose electrons, and covalent bonds are going to be sharing electrons. An ionic bond has to be between a metal and a nonmetal. So that's your easiest way, because you're going to get questions about what type of bond are these atoms going to form. You have to be a sleuth to look at your periodic table and say, hey, that's a metal and a nonmetal. That's going to form an ionic bond. If you see 2 nonmetals, 2 or more nonmetals, you can be pretty rest assured it's going to form a covalent bond. Ionic bonds are solids. Remember, they create solids at room temperature. Covalent bond, it really depends. It could be a solid, it could be a liquid, or it could be a gas. It really depends upon what elements you're working with. Ionic bonds are stronger. That means they have a higher melting point. It takes more energy to break them down. So usually above 300 degrees Celsius. Remember, water boils at 100 degrees Celsius. That's about 3 times the boiling point of water. And then covalent bonds have a lower melting point, not boiling point, melting point, below 300 degrees Celsius. Ionic bonds, because they do have those charges, they can easily dissolve in water. Covalent bonds, depends. We're going to think about water. What is water? H2O. Hydrogen is a nonmetal, oxygen is a nonmetal. So obviously water is a covalent bond itself, and it has charges. So that means that there are other things that could have charges. And we're going to talk about why. It has to do with something called electronegativity, which just basically means how much do they hog, or how easily do they share the electrons that they're quote unquote sharing. We're going to see in water that oxygen's a lot more electronegative than the hydrogens. So the electrons spend a little bit more time around the oxygen than they do the hydrogens. That's why the oxygen gets a slightly negative charge, and those hydrogens get a slightly positive charge because it's not quite equal sharing. But it just is going to mean that it varies on whether or not it can be dissolved in water. Now, ionic bonds are very good conductors of electricity. We're going to talk about electricity later in this course, and I really don't want to spoil it, but just has to do with the ease that metals give up their electrons. That's very important. And then covalent bonds are not very good conductors of electricity. Remember, because if you think about it, non-metals, what are they doing? They're looking to accept electrons. So they're not very good about passing those along. And that's really important when we talk about electricity. So just a good way to see the two bonding types side by side. All right, so remember that ionic compound is a transfer in order to obtain noble gas configuration. Covalent bonds are doing the same thing, but instead of transferring, they're going to share. The key is they still want to look like those noble gases. They still want to move towards stability. 8 valence electrons in their outer shell. So regardless of the bond type, octet rule still must be obeyed. Everyone still wants to get to 8. And yes, covalent bonds, technically they don't get to 8 each, but because they're sharing, it's kind of tricks them into stability. All right, there are different types of covalent bonds. The first is a single covalent bond. This is when atoms share two atoms are held together by sharing one pair of electrons. They're going to share 2 electrons. So the easiest example is hydrogen gas. Each hydrogen brings to the party 1 electron. That first shell is full with 2, so they're going to share those 2 electrons. Those electrons are going to orbit each nucleus. So you'll notice that yesterday when we were doing the ionic bonds, we're just a bunch of dots around here. But I don't see a lot of dots around here. I see a line. And what this line represents is it represents 2 electrons. So this line is an indicator of a covalent bond and that these 2 hydrogens are sharing the 2 electrons. So it's just 3 different ways to see it: the chemical formula, the atomic structure, and then the way that we're going to be diagramming covalent bonds. Here are some other examples. Okay, this is hydrochloric acid, HCl. Remember, chlorine has 7 in its outer shell, hydrogen has 1. So these 2 are the shared pair. This is ammonia down here, all right, NH3. And nitrogen actually has 5 because it's in group 15. Each hydrogen brings 1. So we can see that the nitrogen can share 1 pair with each hydrogen. Now all the hydrogens are sharing their electrons with the nitrogen, but the nitrogen is going to share with all 3 of these as well. Still meeting stability rules, still meets that octet rule. All right, CH4, we have some methane gas. Over here, H2O, this is water. All of these are sharing 1 pair with the atoms that they're joined to. Yes, technically the nitrogen is sharing 1 with each of the hydrogens, so the nitrogen is sharing more than 1 pair, but because they're only sharing 1 pair with each individual, that's why it's considered a single bond. Sometimes atoms need to form a double bond or double covalent bond. Oops. Double covalent bond, I keep skipping ahead, I apologize, is where 2 atoms share 4 electrons, 2 pairs. So what we're not seeing here, and what we really should add, are the other dots, all right, because we still need to do our check to make sure everything has the electrons it needs. So go ahead. I don't know why that drew a line out to the side. It's really weird. So just erase that real quick. Make a new one. All right, so 1, 2, 3, and 4. It's not going to be the best drawing just because it's, oh, did it again. Why did you do that again? Because you have bad formatting, that's why. It's an older version of Word for some reason. Okay. There's 1, 2, there's 3 and 4. Okay, so if we count the electrons around each oxygen, here I've got 2. Let me go ahead and do the laser pointer so you guys can see. Here I've got the 2, 4, 6, and 8. Remember, these lines each equal 2 individually. So 2, 4, 6, 8, this oxygen is happy. 2, 4, 6, 8, this oxygen is also happy. So there can be single, double, or triple bonds. So single bonds occur when 1 pair is shared. Double bonds occur when 2 pairs are shared. And triple bonds, as you can guess, are where 6 or 3 pairs of electrons are shared. So nitrogen has 5 electrons in its outer shell. So it's going to keep 2, and it's going to share 3 different pairs. 3 different pairs. And this is the gas that makes up the majority of the air that we breathe. Yes, we're looking for that oxygen, but nitrogen gas makes up about 78% of the air that we breathe. So we have a nitrogen-based atmosphere. That is it for the notes. So now let's go ahead and take a look at some practice stuff. So I'm going to be working in the Google Classroom. Go ahead and share that screen so you guys can see where I'm at. There we go. Okay, so in Google Classroom, we go down to day 16, covalent bonds, and we're in the notes and practice. All right, we just went over the guided notes. Now we have two practices here, okay? Both are pretty good. Both break it down a little bit differently, but let's go ahead and start off with this one. Just take a quick look at it. I'm not gonna go over it all, but we can kind of go over a couple of these things. So identify the following, if the following would form a covalent bond. So it's either going to be covalent or ionic. So you could just put yes or no. So I see here hydrogen, that's a nonmetal, and chlorine, that's a nonmetal. So is that going to form an ionic bond? Nope. Sorry, it's going to form a covalent bond. So we put a big C for that, covalent. Again, I'm looking for a metal and a nonmetal. So if we look at number 2, we have calcium. Calcium is a metal. Chlorine is a nonmetal. So that's going to form an ionic bond. So ionic bond. Okay. All right, so that's how you're going to do the top. Just tell me, is it going to form ionic or covalent? Don't worry about it. You could put yes or no if you wanted. You don't have to put ionic and covalent. But it's asking, will it form a covalent bond? So you're looking for 2 or more nonmetals. And then down at the bottom, you're going to have to do this part on a separate sheet of paper and send me a picture. That's the easiest way to do this because I want to see the Lewis dot diagrams, and you can't really do those in sheet or Word or Docs or whatever. So there's no real way to do this unless you do it on a separate sheet of paper. So do this, take a snapshot of it somehow and get it back to me. So let's go ahead and diagram just the first 1 or 2. I'm going to do the first one, hydrogen and chlorine. So let me pull up that whiteboard. And if my cat would cooperate and not walk on the keyboard, we'd have a much easier time of doing this. Oh, and you can't teach these kids. Come on now. I need that share and whiteboard. All right, so let's clear this. Erase. All right. So what we're going to do is we're going to do hydrogen plus chlorine. Okay. Hydrogen has 1 valence electron. Chlorine, we know, has 7 valence electrons. Okay. So, and again, this is a nonmetal and a nonmetal, so they're not going to form an ionic bond, right? Obviously, you could see here how it might want to, because there's only one. Hydrogen could give up its 1 and be happy. Chlorine could accept the 1 and be happy. But because these are nonmetals, we're going to see a covalent bond instead. So how do I draw this? I draw the H. It's going to be sharing that electron, so I'm going to make it a line to the chlorine. Now remember, that line represents 2. Which 2 does it represent? It represents these 2 shared electrons. So I'm not going to draw this dot. I'm just going to draw the other 6 around chlorine. So 1, 2, 3, 4, 5, and 6. So here hydrogen's got its 2, it's happy. Remember, it's small. But then chlorine has 2, 4, 6, and then this line counts as 2. So that's 8. Chlorine is now happy. So this is what I need to see when we diagram covalent bonds. Lewis dot structures to start off with, our little chemical equal sign, that arrow, yield sign, and then boom, our lines with the dots around the atoms that need them. A mistake that I see people do a lot is they'll do things like this. They'll do the H to the Cl, and then instead of just putting the 6 dots around them, they forget to take off the 1, and so they just kind of have it here. This is wrong. Don't do that. All right. This line right here, right, that represents 2 different electrons. So the key here is that you have to take that into account when you're counting up to do your check to make sure everything is now stable. Okay. No, you can't sit there. I'm sorry, you can't sit there. All right, if we go ahead and take a look at the second practice very quickly. So go back to sharing the screen. All right, go back to classwork. Now let's take a look at the volume practice number 2 real quick. Okay, just like the chart that we had yesterday, here you're going to be taking a look at these atoms, how many protons they have, how many total electrons they have, how many of those electrons are valence electrons, and how many will take to fill the outer shell. So if we're looking at carbon, carbon is element number 6. That means that it has 6 protons. My number lock is on, that would have a 6, there we go. It has 6 total electrons. Of those 6 electrons, it's in group 14, so only 4 of them are valence electrons. So how many does it need? How many bonds does it need to make? How many electrons does it need? It needs a total of 4. So carbon is a very interesting one because it has 4 unpaired sides, and that's where it's going to look to make bonds. So it can make up to 4 bonds. So carbon is very important for life and the complexity of organisms. So go ahead and fill out the rest of that chart for me. Then down at the bottom, again, we're just going to be diagramming some stuff here, just like we did before. Lewis dot structure, arrow, and then the answer with the correct bonds for lines. Taking a quick look at this. What they did here is they gave the atoms, they didn't give you the numbers. So some of them might need more than 1 to become stable and happy. So look for those unpaired sides. Looking specifically at nitrogen and hydrogen. Remember, nitrogen has 5. That means it has 3 unpaired sides. So you're going to need at least 3 hydrogens to make that molecule happy. All right, so that should be it. This one is very, very simple. None of these look complicated at all. These are also fairly easy. Phosphorus and sulfur you might have trouble on. Number 18, we're going to make that one a little bit of a bonus, but you should be able to get the rest of them, no problem. If you guys have any questions, comments, or concerns, don't hesitate to reach out. Remember my email, nick.welsh@excelcenter.org, or you can message me on Facebook, Tech Nick Welsh, or you can message me on here as well. So plenty of ways to get in contact with me. There is an X ticket after that, so just go ahead and click on that form, fill that out, and get that turned in. And when this is done, the video will be added to the class videos as well. All right, guys, hope you learned a little bit about covalent bonds, and I will see you on the Zoom tomorrow. Have a good day.